Well, welcome everyone to this last session of the semester, the Computational Political Science for Democracy Working Group. I'm very pleased to introduce Andreas Beger, who has come here. And the reason that we invited him was that he worked with Rick Morgan, who was then a postdoc at the Vietnam Institute to develop a way to try, an attempt to forecast transitions involving democracy around countries in the world using VDEM data. And so they produced a variety of predictions and they evaluated the predictions, and that's what he's going to be talking about today. But in preparation for a conference we're holding in October, we're just scanning the world trying to find anybody who's used something like AI to forecast democracies. And I think the Beger Morgan project is probably the most, the closest thing there is to that. I think he's kind of at the forefront of attempts to forecast democracy using computational methods. And so I thought it was just essential to hear from him this semester in this working group. And fortunately, he came to the Midwest Political Science Association meeting in Chicago, and we were able to persuade him to change one of his flights so that he could come be with us at Notre Dame today. So welcome, Andreas.
Thank you for the introduction, Michael. I'm a long lost political scientist. It's a long time since I've been in a room like this, giving a talk. So I think it may actually be my dissertation defense.
We're very comfortable.
For now. So this is going to be a little bit unusual. I'm not in an academic position, and I haven't given a talk like this in a long time. But it's really interesting, exciting, because when you're out of the academic world, you don't get to talk in depth about things like this. And so, I'm really excited to see if we can have some interesting discussion.
I forgot to mention he's living and working in Estonia.
Yes, I will. So one of the unusual elements that I like people in the business and tech world use, and I'm going to do this as well, even though it's not usual in academia, I think when I was still in it. Just to talk a little bit about yourself in the beginning. I want to assume that Google stalked me and so I have worked in Granville for about 14 years now. So basically, since I finished my PhD, I've worked as a consultant in a sort of niche area. The domain is still related to political science, but like I said, I'm not in an academic position. I instead work as a consultant for sort of governments, NGOs, and other also university clients who have sort of work with further down the line NGOs or governments. My sort of formal employer and position title has varied, but basically I've been doing the same work for a long time. In terms of the actual topics, sort of a lot of it has revolved around forecasting and early warning systems. One of the first things I worked on when I finished my PhD was a product called IQs. A lot of people know it for the event data, but there was also actually a forecasting component to it, and that was like the first thing that I worked on. And so these forecasting systems, some have been on conflict, but not exclusively. It's also been instability and governance, like the project that I'm talking about today, more broadly. Sort of through path dependence and kind of following where the projects go, I've now ended up strangely working mainly on automated event data. So taking the kind of coders that produce data like IQs or GL and basically adapting them for straight area transformers and large language models. Yeah, as Michael mentioned, I'm based in Estonia. My partner is Estonian. I married with a visa. That's how I ended up there. Before that, I was in the US for about 15 years, but I'm originally from Germany. I'm not German, it's complicated. The US is a melting pot. I came pre-mixed. Yeah. And then, yeah, sort of outside of my work, I shouldn't have said academia. That was a Freudian slip, I guess. But I'm also sort of one of the things that is of interest to me and as a result of which I do these things that I'm going to mention is that kind of generally interested in software development and computer science on that side. And so I'm back in Estonia involved in the local data and tech community. I regularly organize sort of meetups and stuff with people who do data work at tech companies. And also something that I'm personally proud of, I'm on this sort of multi-year project to give myself a more sort of homebrew computer science foundation. Just proud of it, but the reason I mention it is because it kind of influences interests and the way I do work, and specifically data scientists are known for writing terrible code. My ambition is to do better. I don't know if I always succeed, but I'm hopefully going in that direction. And as Michael already introduced what I will talk about today. And so before I talk about that, one of the discussant feedback at Midwest was that we have a paper, we don't have a hook, we have no motivation. So expressly, I have now tried to explain why forecasting might be useful and of interest in this domain. I think in this room, probably, I assume most people don't have to include it, but let's see. And okay, example number one. This is polyarchy, the electoral democracy index for the US. I've done this with all the recent BDAM versions, so each color line is a different BDAM version. That'll be a point I get to later. I'm not going to talk about it as much as I did at Midwest. So for those of you who saw this presentation before, it's going to be different today. But as we all know, there are some unusual things going on currently regarding governance in the US. And so this is literally something that happened after our panel. I was at one other panel. It was about environmental sort of political economy, something like this. So it wasn't about governance and politics itself, but at the end of the presentations, the discussant was talking about one of the projects was about companies' exposure to environmental regulation and how that might lead them to sort of emphasize ESG, kind of basically greenwashing, or maybe actually putting effort into sort of reducing their carbon footprint. And he mentioned that in the US, the regulatory environment might change with the next administration. And so more or less at this point now, quoting exactly, we'll have to wait until 2028. He caught himself with a short pause and then said, well, who knows? And everybody in the room caught that pause and understood what it meant. And which is, yeah, it's not that clear anymore how things will go in the midterms, how things will go in 2028. And so, it's not clear if you're looking at the graph, which direction are we heading in the future? On the more optimistic side, this is Hungary, sort of one of the canonical examples of what we thought were stable democracies, which sort of backslid into up until now, hopefully, competitive authoritarianism. And so they just had elections, a big deal. The opposition party managed to win, and not only did they manage to win, but they managed to win a supermajority. So maybe unlike in Poland, where the sort of equivalent also lost power recently, maybe in Hungary the Fidesz and Magyar will have enough sort of electoral legislative strength to undo a lot of the sort of not so good for democratic governance things that Orban did under his, was it 16-year rule? And so there's a lot of optimism, but again, is this optimism justified? And I think there are good reasons to expect that it is, but we don't sort of, I think right now, have a really sort of data-informed baseline for what we should expect the future to look like. And so just generally speaking, I think when we do have data like the plot that showed you, it's sort of probably looking three things that we can do. And this is not just in governance. I see this also in sort of the conflict world of time. The first thing is just monitoring. So early warning, usually often people use the term concretely just for monitoring. So just establishing what is happening right now. And the utility in that is that it really forces you to actually have data to have an empirical view of the world. And so in that sense, it forms the foundation for everything else. And then of course, in academia, the main emphasis is on explaining and understanding, so a causal model. We want to understand, why do some countries have more democratic governance, some less, and why do they sort of change in that regard? And this is crucial. Of course, I don't have to convince anybody here about this. But the drawback is that usually this is done with historical data, so it's not unusual in public work. At least the one I'm familiar with, to see sort of data that ends 5 years ago or maybe 10 years ago. And it's also it can be hard to, so if you're interested in a specific case, it can be hard to kind of figure out what is all the published research and sort of accumulated body of causal knowledge telling me about this case in particular. Hungry. And I think maybe more concretely, if you think about the sort of current vanguard of the way to do causal inference, which is sort of to have these very, very focused, carefully specified models. We're talking about DAGs and sort of specific criteria for what control variables to include in a model or not, or difference in difference, finding actual experiments. These things are explicitly focused on one factor, just one factor at a time. And so if you have 10 pieces of paper that do that, what's the overall nature? It can be a little bit hard to establish. And so one of the things that forecasting does in that regard is that it really forces you to think about how to integrate these different pieces of knowledge. It's challenging, and sort of in the work that I have done, mostly we have not done it. I know Michael and you and your group are sort of doing work on that. Yeah. And I think the other thing is that I would argue one other reason that forecasting is useful for basic research, fundamental research in political science is that it really helps you establish what the current limits of predictability are. And I have encountered cases in the past, so just speaking from personal experience, where people who do causal modeling aren't necessarily aware how causal modeling relates to predictability and forecasting. And specifically, things like statistical significance don't necessarily mean that whatever variable is statistically significant is actually a good predictor. Might not be a good predictor at all, might not be important for prediction at all. Conversely, things that are not statistically significant can be important for prediction. And not just in the trivial sense of like, if we want to predict murder rates and we have ice cream sales, let's do it, which we can do in the forecasting book. But I mean, in sort of a deeper sense, things that you might not expect to be important turn out often to be important. And so that causal sort of knowledge of the causal work in a field doesn't necessarily translate to knowledge about what works well for prediction and forecast. And then from the other perspective, sort of from the people who commission forecasting work, also from personal experience in political science, it's hard to publish forecasting work in peer-reviewed articles. Just on a basic level, if you have a 1-year head forecast, by the time your article is published, it's sort of pointless. But it's just basic. But even beyond that, a lot of forecasting work is simple. It's not scientifically necessarily that interesting. It's sort of the values in the forecast that you provide, the methods themselves are maybe not necessarily always that innovative. And the project that I have here, I would argue the methods themselves are sort of pretty bog standard, I would argue, kind of forecasting approach. But so again, going back to sort of from the other perspective, so there is a lot of interest, especially like in the conflict community. They want forecasts, and the utility this stuff serves in that world. And it's a world where oftentimes you're competing with analysts, not competing, but where the status quo or analysts who do qualitative work, who are country experts and stuff like this. So there's a lot of tension and kind of two-way challenges that way. But I think for organizations, one value is that it helps with problems like resource allocation. So country experts are great at understanding a specific situation, but how do you sort of bridge, country experts from different countries? How do you know, which kind of country expert that's screaming at you that the situation is bad to pay attention to? So that's one of the ways that organizations use this kind of stuff. They do also use it for its own part, sort of clarity. They can serve this role, and I would argue also, I don't necessarily that people in the practitioner side view it this way, but I sort of came to view it this way as a result of a project I did years ago where we explicitly tried to investigate how you combine human judgment with sort of model data-derived judgment. And I think one of the big utilities or potential utilities of quantitative forecasts is the anchoring base rate. So we know from like Phil Tetlock, judgment, and all this stuff that one of the really important things for making good forecasts or judgment about the future is just knowing sort of what is the data-based expectation that I should anchor my judgment on. And usually you do this just like, let's say in the coup world, any given country in a given year has a 1% chance of having a coup. So you really got to have a lot of evidence to argue that, yeah, this country has a high risk of coup. And I mean this like in an analyst, like qualitative judgment sense. And what models can do is instead of having just like this is the global average of coups in a given year, or this is the global average of like backsliding, however you define that in a given year, you get a more refined base rate that isn't just sort of one global average, but it's sort of more variable across countries. Okay, on to the meat. So I will review the work that we did 7 years ago. And so this was a larger project that Rick and I and Laura Maxwell and other people at BDEM in Sweden at the time came onto at a later stage. The actual sort of starting origin was a qualitative effort, which was done by IRI, funded by USAID, and they developed a framework of 6 different spaces, or 6 different, they call it spaces, but let's say 6 different facets of governance that they thought were important for understanding the nature of sort of from democracy to autocracy of governance. So this was in place when we joined. We just simply mapped these to corresponding, BDEM indices. And then the other sort of thing that was a constraint we dropped into was that they were interested not just in backsliding, which especially at the time was sort of very, very relevant because Poland and Hungary were kind of in the midst of their decreases. But they were also interested in opening, obviously, sort of, how can you do something to change the direction that Poland and Hungary and other countries like that were heading at the time. And so for us, that meant we don't want to forecast just backsliding, but also the possibility of re-liberalization. So the way we translated this into data was to basically ask whether there was a large, so we had 6 different BDEM indices, and the thing that we wanted to forecast is whether there was a large increase or decrease in one of these indices in either one of the 2 years ahead. So either a decrease next year or a decrease the year after that, or both, whichever one, that's what we're going to forecast, or correspondingly also increase, like a liberalization. The 6 indices that we use, they don't all change over time in a similar way. Some tend to be more stable, others tend to be less stable. And so we use 6 sort of different space-specific thresholds to kind of judge what is a large increase or decrease. Later, we kind of discovered that doesn't necessarily. So before I do that, let me the basic initial version of the way this worked is that so the orange bars reflect kind of the threshold that we established for a space, and we're just looking like year to year, does it exceed that threshold if you look at the change? And in this case, the first year T+1, it does. So this is something that we would this is an opening movement that we would want to forecast. But the subsequent year, so if you have the new thresholds based on the value of T+1, it doesn't, and for that year that we would have considered that to be like an insignificant no movement. But overall, in the 2-year period, because we had an up movement, we would call this like an opening. At some point, we realized that this doesn't capture actually slow burn changes like Poland and Hungary that well. And so we kind of tweaked it a little bit so that it had, like, let's say, it moves a little bit here and a little bit more here, but overall you get over this 1-year threshold, will still count. And so this gives us like a binary indicator answering this question about for each of the 6 spaces and for each of 2 directions. So 12 total binary indicators that we wanted to forecast. The models themselves were random forest models. We sort of decided right away, I think I was the one that kind of pushed for this. It's like, we're not going to try to do like a regression, manually specified equation type thing. Like, if you want to do forecasting, it just doesn't work very well. Random forests are sort of very, you just throw things into the hopper, they figure it out, and you get forecast out. We also considered sort of another version of this, gradient boosted models, XGBoost. I'll mention that in a second. I think at that time, they both work very well in terms of forecasting accuracy. We were just more familiar with random forest, so we went with that. On the lower complexity scale, we also tried out regularized logistic regression. So again, you just throw things into the hopper. Now the model, though, has just linear relationships, sort of on the big scale, but linear relationships, and then there's regularization, meaning that some of these coefficients get pushed towards zero, based on whatever results in the best predictive fit. But that didn't work as well. So there was a lot of utilities using random forest model, because those can do things like model nonlinear relationships. They can also model sort of higher order interactions. So two-dimensional sort of, how do two variables together jointly influence something, and arbitrarily higher, which I'll get to. You'll see that I will get to it in a second. Again, for the predictors, we started out with 460 roughly. A lot of these came from the VDAM data itself. So all the high-level indices, including the indices, the 6 ones that we used to construct our outcomes, different kinds of transformations, moving averages, standard deviations, stuff like this. And then we had indicators from a couple of external data sets, conflict stuff like civil war, is a country fighting a civil war, or interstate kind of dispute conflict, ethnic power relations, Archegos data on state leaders, so how old are they, how long have they been in power, coup stuff, how long has it been since the last coup attempt in a country, and then sort of basic structural stuff from the World Bank, population, GDP, infant mortality. And this is how it worked out. This is the accuracy that we got. So as good forecasters, as part of our development, we did test forecasts. So this is what you see all the way on the left. This is where we say first time we did this, we were using the V9 version of VDAM. So we were using V9 VDAM to construct our predictors. We were using V9 VDAM to construct our outcomes. And we just kind of pretended that the year is not 2019, it's 2010. Let's apply our procedure, create forecasts, see how well we did it, move 1 year forward, do it again, blah, blah, blah. And that's how we get the dots all the way on the left. And so each color is one of the forecast sets that we did. We did, 6 overall. So the initial set of forecasts, and then we did a couple of annual updates where we threw out new 2-year forecasts. And on the basis of the test forecast, so those are AUC ROC values around 0.95, which is really good. Sort of coming from the conflict forecasting world, you sort of expect 0.8 is about the limit of what you can do. And so, we were really happy and excited. We thought that we were doing really well. And then 2 years later, when we had the VDAM version that covers our 2-year window, so where we can actually assess our live forecasts. So for V9, this would have been V11 VDAM for the forecast that we made. With V13 data, this would have been V15. There was a sudden dramatic drop in performance, which was disappointing to us. This is around the 0.8 that I just mentioned is kind of like what you expect to get in conflict worlds. So this is still good. It's still okay. It's definitely informative over if you do base rate, positive rate informed guessing, 10 to 15% for outcomes. So this is still informative. But we thought we were doing a lot better. And one of maybe the biggest reason that this is the case is that the VDAM data, so each time the VDAM data are updated, all of the data are rebuilt, and the historical data can change, they get revised. And so for us, this is the rule of law index for Pakistan. Each colored line is a different VDAM version. And so you can see that, this is one of the more extreme cases, but it's not sort of completely unusual. You can see that there are changes up to, let's say in 2008, 2019, if you look, we thought it was, so if you look at the minimum maximum value between different versions, it changes it up to 0.1 on a scale that ranges from 0.1. So this is quite dramatic. And yeah, sort of about 20 to 30% of cases have changes in these indices that are above the thresholds that we're using. So this basically means we're forecasting the ground is shifting under us. And so by the time we score the forecast, kind of the picture of the world has changed. I spent more time on this in MPSC. I'm not going to talk about it again, but sort of, I will come to the defense of VDAM again. I think I will, yeah. This is not a fault of VDAM. I think VDAMs, I think 70% of this, let's say, guessing, is VDAM exposing things that all other data projects have. And that thing is that it's really hard to get humans to agree on complicated concepts. We're all dealing with complicated, non-trivial concepts. We're not trying to decide whether this image has a cat, or whether this part of the image has a bridge or not. Democracy, rule of law, these are like incredibly complex things. I have run annotation projects for event data with Cameo event. So this is like you're trying to protest or whether somebody made a statement indicating like the provision of material support. And you just can't, like there's lots of room for disagreement. Doesn't matter whether it's like the equivalent of undergraduates or whether it's the equivalent, not the equivalent, but people with PhDs in political science. It's really hard to get a high level of human disagreement. 70%, I think, is stuff that all other data projects have. It just, to end users, is not visible because usually data sets just tack on a new year of data. And they don't expose really any underlying coder agreement to you. I think, sort of the modal way this is handled in coding projects and the way that I have handled it in the past, I admit it, is that you have 2 or 3 people coding something. And if you see that they disagree, an expert swoops in and sort of makes a decision on what the right call is. And I have done coding where experts are the ones coding and they don't agree. So this doesn't solve the problem. And the other 30% are maybe things that are sort of more esoteric, related to this like distribution shifting and how that impacts the measurement ones. I don't know, I'm just spitballing here, but I think this would be a super interesting thing for somebody to dig into. I don't know if anybody has. The other thing that I think I would be curious to know is whether you can sort of model and predict which cases will change a lot. My suspicion is that like the interesting cases, the ones that are very like where the situation is fluctuating a lot, are the ones that will have the largest changes. But I don't know if that's true. I just don't know. And I don't know if anybody has kind of tried to do that.
Yeah, past regime changes are a good predictor of future regime changes.
Yeah. I mean specifically about like coders changing their coding or something.
Oh.
Can you model when coders go back in time and change, or can you model like how much disagreement there is between coders? I don't know, but so that was the model itself, and then I want to talk about one thing that we didn't do explicitly as part of the way the forecasts were presented or anything like this. This is something that I did. So in 2021. I did an update to the forecast. And so my job was just to update the data, run it through the pipeline, get a new set of forecasts, update some dashboard, and that's success. But while I was doing that, I noticed that France had an unusually high risk of foreclosing in one of the spaces, which we used the civil society index. And I was afraid that I had done something wrong. So I did kind of a sanity checking investigation. The reason I want to talk about it here is because it touches on something that I will move on to next, which is kind of looking at the future, what I would do differently. And so anyway, so the most Western European democracies just don't have like high risks ever on this stuff. Like they're very democratic, they're very high on all these index values. They don't have a high risk of decreasing, but France, for some reason, when I was doing the update, popped up in like if you look at if I looked at the top 10 like forecasts for the space globally, and France was in them. It was not in the top 5, but it was in the top 10. Okay. When these kinds of things happen, I've done many forecasting projects, then usually the first thing is that you did something wrong and you had a coding error, which is why I did this. It turns out I didn't. These things were fine, but I'm going to go over why I think that's the case. So anyway, so the risk for closing was 0.59 in the last year. And I just want to mention before I move on that that's like not apocalyptic. We're talking about like a 0.5 roughly, the risk of a 0.5 decrease in the civil society index. So it doesn't mean you become North Korea right away. But it is like a weird and significant movement and risk for France. And so I started looking first at the things that you also do. So individual conditional expectation plots, partial dependence plots. You can sort of tease out if I vary the value of each input that goes into the forecast, how much does that change the risk that comes out of it? So I did these kind of univariate investigations, and I found something weird, like that didn't make any sense. This is the individual conditional expectation plot for the number of years since the last Powell and Vine coup attempt. So like Mali had a coup, I don't know, probably 4 years ago, so that Mali would have a value of 4. And you would, as you just mentioned, the best predictor of future regime instability is past regime instability. So you would expect that the more time has passed since you had a coup attempt, the lower the risk that comes out of the model is. And in this plot, each line, let's start with the points. Each point is a country, and it's the risk that comes out of the model. So the y-axis is the risk that comes out of the model. The x-axis is the value that that country has, or the number of years since the last coup attempt in that country. The lines are the trajectory of the model predictions for that country when you vary the number of coup attempts. Anyway, so what you'd expect is that the risk decreases the more time has passed since the past coup attempt. But we don't see that. We get this weird spike here at the end where countries that haven't had a coup attempt in a long time, for some reason, see a sudden increase in the predicted risk, which is just theoretically I still have some political science knowledge left, and this is just weird. It shouldn't happen. And the clue is that this is an artifact. So the countries that have the maximum value of this is actually an artifact of what you do with countries that have never had a coup attempt. And so in the way we constructed the data, we count the number of years since a coup attempt, if you had one. If you didn't have one, it's the start of the data or whatever year you reached independence first. And so these countries that are all the way on the right, those are countries that never had a coup attempt since 1950. Yeah. And then the ones that are here are that never had a coup attempt since they decolonized and reached independence in the 60s. So this isn't about coup attempts. This is about some coding artifact that we had. And it turned out that those 39 countries that have the maximum value, those are most of them are OECD countries that are stable, that have never had a coup attempt. And usually, like I just said, they're stable. You wouldn't think that anything's going on there, but it turns out actually they used to be stable. This plot shows the number of closing events in that space over time in that set of countries. And they used to be stable for a long time, but they're not anymore. And the model was picking up on that. So the model was using that variable to identify this cluster of countries whose sort of stability had changed in time. And that's why we have this weird association. So this is a weird thing about random forest models and XGBoost models, but that isn't really what explains what's going on. And it turns out, in fact, there is no single explanation. And this kind of speaks to the part of why random forest models or these kind of more flexible models are better at prediction in this case. So no single one factor, if you change the values, no single one factor gets that risk probability from 0.95 to dramatically down. It doesn't. You can look at combinations of risk factors, which is what I did here. And so digging into the data, it turns out that France had unusually, so if you compare to other Western European democracies, it has unusually high values for the sort of changes in the civil society index. So unlike other countries that had seen some variability. And it also has a higher value for anti-systemic movements than other Western European countries. And then I already mentioned that it has this maximum value since the last coup attempt. And so I did an experiment. What happens if you set the value of, this is just the points from this individual conditional expectation plot I showed you before. So this is just the for anti-systemic movement, like index the value. This is for the standard deviation, the core civil society index over the past 10 years. And then this is the number of coup attempts, or the time since the last coup attempt. The y-axis are the model predictions, and each point is a country in 2020 or 2021. But and I got rid of blinds, and instead I just highlighted France, and so how it evolves when you set its values to the values of other countries. And it turns out that if you set the value of France on these two variables to the average for other Western European democracies, Germany, France, Italy, and Spain, and the UK, then you can get a large drop in the risk. It goes from 0.59 to 0.39. That is still high, but it gets it out of the top 10. And the point is, so one of the points here is that, yeah, this stuff is, yeah, there's not just one single thing that causes everything. This stuff is complicated. The other point I think is that these models they're flexible enough to kind of use interactions like this. And this is a sort of basically, in some way, I guess, a 3D interaction. And there's a lot, basically, room to dig into what these models are doing. And I think hopefully I've kind of shown you some evidence that you can do this in interesting ways. And so let's look at what I would do differently. Let's get the easy stuff out of the way. In terms of modeling overall stuff, I would actually keep it simple, so similar to what we did before. One thing I feel quite strongly about is I wouldn't use random forest models. I would switch to gradient boosted models, XGBoost. They're in some way actually simpler than random forest models. They're definitely quicker to train, quicker to iterate. But in random forest, let's model, let's say you grow. In our case, I think we had, I remember we initially had 1,000 decision trees in each random forest models, and later increased that because there was too much variability. In a gradient boosted model, that you only have a couple of trees. They're just trained in a different way, so you utilize the sort of underlying weak learners or decision trees more effectively. Performance-wise, they do as well or better. And in industry, for sure, like anybody in industry who's dealing with what they call tabular data, which is what all this stuff is, like panels and everything we do, or most of the things we do in political science, they will call tabular data problems. They just use XGBoost or there are other versions of gradient boosted models like light GBM and CatBoost and they just go straight to they just random forest are like passé for them. I think there's some maybe some way to play around with the what you model as the outcome. So do you kind of discretize first, create binary indicators, and then you model that? That obviously sort of doesn't work very well with the historical data revisions in VDEM. So maybe it's better to model the levels or the changes in levels on the VDEM indices first. Maybe that is more robust to these historical revisions. And then if you need to discretize representation later, you can do that down the road. I don't know if this is something to experiment with. And then in terms of outcomes, also I think the way we constructed outcomes was overly complex. I would just, if I did this again, I would just say okay, what's my I would also do 6 versions of this, but let's say what's my polyarchy score now? What do I think is going to be 2 years from now? And then if I want to capture slow burn changes, I just look 5 years from now. And that'll get me Hungary, that'll get me Poland, but I also have the 2-year version, because 5 years is a long time. But this is I would say, easy stuff to do, and where I would rather put my attention is in 2 other areas. The first one is sort of in connecting it back to science. And I mean, specifically here, 2 sorts of things. One is looking at variable importance. So there are kind of off-the-shelf interpretive machine learning methods for determining, even with these kind of nonlinear models, which variables play a large role in the predictive performance or accuracy of the models. I did that accidentally, not for this purpose. I did that accidentally during one of the updates. The reason I did it is because I was trying to simplify how much data we're slinging around. And so I looked at the variable importance for variables coming from different data sources. And it basically turned out that the conflict stuff doesn't matter for predictive performance. Just throw it out. It's weird, but it doesn't seem to matter for predictive performance. So I just got rid of it. The Archegos stuff, so state leader stuff, didn't matter a lot for predictive performance. Threw it out. Power relations didn't matter for predictive performance. I think part of the reason is because at the time we were doing this, the data had last been updated in 2017. But also generally the I think power relations stuff tends to be pretty static over time. So I think that also just is why it doesn't seem to matter that much. And then we also cut variables in other data sources. So overall, we cut the number of predictors in half. And that was just purely because to reduce the burden of producing these forecast updates each year. It turned out it actually strangely also it definitely made the models faster to train, but it also made them slightly more accurate. And I think part of that is because all of these models in principle are able to do feature selection. So in the random forest model specifically, they randomly sample cases and columns to train a decision tree, and then they just do it a bunch of time to get 1,000 or 2,000 or whatever decision trees. And it turns out, I don't know this for sure, but I think if you're eliminating sort of useless features, you're basically helping them. The model doesn't have to do as much feature selection. So with the given budget of trees, which we had here, we didn't change the number of trees. You basically make each sort of decision tree that goes into the random forest slightly more accurate because it doesn't spend time on sort of actually unnecessary or unhelpful features. But I did this kind of just as a work process thing. But actually, knowing which features are important for prediction, as I mentioned earlier, it's not trivially easy to predict from sort of what you know from causal modeling. And so I think there's actually interesting sort of information going back to the causal modeling work on this. And then the other thing is that, and we didn't do this at all, except for this France what-if investigation that I just showed you, is looking at how the predictors relate to what comes out of the model. And with this number of years since the last coup, it didn't behave as you would expect, which is weird. But I think generally it would be nice to see whether the relationships kind of correspond to what you would expect theoretically based on existing causal work. If it doesn't, I think that's potentially interesting for the people who do causal modeling to know. Maybe, I don't know. And then I think also this is with these models you can investigate higher order relationships. And so this is hard stuff to do once you get beyond more than 2 dimensions. But I think this is an potentially interesting area to explore. Or how the different sort of things that we know are individually causally related maybe to governance, how they're maybe sort of interact with each other. And then I think going back from science to the models, I think the models we use, they themselves cannot establish anything about causality. It's just all things, predictors go into the hopper, predictions come out, the models themselves don't do anything related to that. But I think in principle, I think you can try to see how the things that the models do match or don't match with theory. And to the extent that the things that do match in theory, I think would be very nice to have when presenting results for non-technical consumers. Because people look at forecasts, even if we explicitly try to not facilitate any kind of causal thinking in the way we presented our forecast. This was just, we decided we don't have the budget, we don't have the time to do this well. But I think what would be really cool is to be able to tell people down the road, because they want to know. It's okay, so this factor is related to the outcome. If I change it, I can invest, in sort of open society kind of events in the country. If I do that, will that change the risk? Causal question, obviously. And I think if you know from external sort of expectations that, yeah, usually this works this way, then you can also tell them within this model that, yeah, I think then you're on safe ground. You can say, yeah, if you change this, then according to the model, you will see a change like this. And we just, we didn't do that. But causal questions come up all the time when we're forecasting crowds. And it's just a very dangerous territory because these are usually people who don't have the domain knowledge to know what's kind of published in political science and other research. So that's one thing. The other thing that I would do differently is picking up from sort of how the results are presented and how non-technical consumers understand and use these tools. And one big problem is that a lot of the people who consume stuff like this, they just, like, even probabilities are a challenge. So if you say that, like, there's a 59% chance of France decreasing, it's because they just don't, doesn't necessarily know what to do with that. And so the other thing is they want to understand why it's 59%, or they want to know why is France higher on this than Germany? Why is France higher this year than it was last year? So they have questions like this come up all the time. I used to do, this is a long time ago, I used to do monthly forecasting reports for sort of for government agency. And as part of that, so I had a lot more kind of cases like this where like France, something is weird. And so when I was doing these monthly reports, as sanity checking, I would do a lot of these kinds of investigations of like, okay, why did it increase? Why did it decrease? And there's lots of stuff you can do to help explain why something is the way it is. And so a lot of this leans on, like, there's something called interpreter machine learning, which are tools and methods to kind of dig into what used to be called black box models, so random forest models, gradient booster models, so maybe deep neural nets or shallow neural nets, these kinds of things. There's a lot of tools out there nowadays to use, and you can combine these tools and other domain knowledge in interesting ways to help understand sort of what a model is doing under the hood. And that's of a lot of interest. That's of interest to people who consume these kinds of forecasts. And so this is really where it would be nice to have more resources and time to dig into. And I think sort of we are in the age we are. Everything is AI and LLMs. Whatever pressure you guys feel in academia, it's even worse in business. And so I think this is where I would really see maybe the potential for LLMs. So I don't think you can use LLMs to replace these kinds of models. They're just not, they don't do that. You can use them as like human annotators. They can do that if you know how to kind of few shot and prompt them and everything. But I don't think they replace these kinds of models. I think you can use them for creating new kinds of data. They're really good at extracting kind of text, extracting knowledge from text. That's like what they do. And there are lots of sort of graduate students and people that were doing like really interesting work in terms of how to use LLMs for innovative way to create new data. But I think the one thing that I would really be curious to know is whether you can use these things to facilitate, kind of basically help non-technical consumers understand these forecasts. I think the basic way you might go about this is that you give them access to tools like this interpreter machine learning tools. You give them some examples of cases where you answer specific questions about a specific forecast. And, if you let them loose in the wild, can they help people understand these models correctly or not? I don't know. But this is kind of where I would say the role for LLMs, these kind of ChatGPT style models is. And I think I would also mention this is the like least scalable part of this law. You can, if you could get an 80% kind of forecasting model, a basic forecasting model, in maybe like 4 weeks, let's say. So it can, do this something like this and like a very basic one, maybe let's say 4 weeks. I think you could do the sort of basic version of this kind of like, if you've done it several times before in your life. But, basic minimum viable product kind of version. And I think similarly, if you've done this many times, you can do a sort of basic, like how do these variables relate to outcomes? Which variables are important for prediction? You can do that in a couple of weeks. But this kind of like explaining specific cases, why is this forecast high or not? Why did this forecast change? Now you're not just looking at 250 predictors and 12 outcomes. Now you're looking also that X 160 countries, X, let's say people are generally interested in the most recent 5 years. And it's just an infinite pit of like things you could do. And so I think this is where LLMs would have the biggest potential. Okay, so yeah, I would keep the modeling simple. And I have the luxury of doing this. This really doesn't work well if you're trying to publish peer-reviewed research because you're not really doing anything innovative in that sense. And I think if anything, I would invest into new features. Like one of the things that I would love to have available as predictors, data on elections, but not when elections happen, but at any given moment in time, when did I think the next election would be? That is what I would like to have a feature. I don't know if that exists. I think it doesn't exist, and I think it would be difficult to create if you're going back to like 1916. And then so instead, really what I would do is dig more into the model, both in a sort of scientific sense of how do these, what does the model tell me about the relationship between the inputs and outputs? How does that relate to previous work? But then also looking towards non-technical consumers. How can you facilitate and help explain the results that come out of these models to people who are not comfortable with numbers, who don't know what these things are, who are not sort of familiar with data and stuff like this. All of this stuff we did on this project is publicly available, including like the stuff I did for this presentation and the one last week. So if anybody's kind of interested in what we did, it's all publicly accessible, and you can in principle dig in.